So today's problem is basically called maximum score of non-overlapping intervals. So actually, I think I wrote recorded was part of this video a while back, but I need to record it again because somehow the audio was turned off. So yeah, so what my idea of explaining this problem is I will basically give a very small summary of what this problem is, and then after the after the summary is complete, I'll basically go through the code, and while going through the code I will give you more finer details of what all things are required to solve this problem, and that would basically also help in you understanding the problem even better. So that is the approach that I will take. I think this problem was asked in Leetcode weekly context for 431, right? And this is a pretty I think relatively recent problem. Looking at the number of the problem 3414. Okay, so without any further delay, let me give you a small summary of what this problem is. So basically what this problem is, it will give you a list of intervals. Each interval will have a weight, right? And the intervals are all jumbled up, they're not sorted by any order, they can be like in any order. And then our task is to figure out uh, groups of at most four length intervals which have the maximum weight, right? So basically, our answer has to be a group of four intervals. But another important property of the group is that all the intervals have to be non-overlapping, right? For example, if suppose and these are three intervals are given, we have to take group of four, but just for the sake of explaining, I am taking three intervals. So suppose this has L1, R1 here, this is L2 here, left end of the middle interval, and this is R2, this is L3. L3 has to be strictly greater than R2, and L2 has to be strictly greater than R1. So you understand this is the basic meaning of non-overlapping intervals. We need a length, maximum our group length has to be 4. Our answer has to be for such a group, our answer has to have the maximum weight. And if there are two such answers or two or more such answers exist, then we have to take the answer which is the lexicographically smallest. That means which has the left the left boundary value of the first interval in the list as the maximum, right? Sorry, pardon me, as the minimum. So what you have to do is basically we have to order the list, I think based on the start times, and then once that is ordered, then what we have to do, so this non-overlapping list also is ordered uh, based on start time. So then we have to if there are two such answers which exist, right, then we have to basically take the first value here of the first interval, left value of the first interval or the first group, and the left value of the first interval the second group, and then compare them, and whichever has the smaller value will be given the more priority, and which will be returned as the answer. So this is about this. And also one peculiar thing about this program, this is more uh, programmatically relevant, is that we need to also return our interval. In what way? So when in our input intervals we have this ID, because obviously our input is a vector of vectors, and each vector, each of the internal vectors are itself intervals. But obviously since there it is an input, so it will have a zero indexed ID, and we need whenever we return our answer, we need to return that original ID which was given in the input of the interval, right? So we need to store that ID somewhere. So right, so with all this background, let us go dive into the code and see how the code is solving this complex problem. Okay, before one more thing I would like to mention, this program, this I mean this question is very difficult. It has complex dynamic programming involved, and a lot of and if you want to make the code readable, you have to use a lot of C++ concepts, and also I think readable and precise. If you want to keep and short, you need to use a lot of C++ concepts, and there are a bunch of tricky edge cases which you also need to like. navigate through in order to reach the answer. This is yeah, this is marked as hard, and I personally think this is a pretty hard problem of lead code. And there are not too many solutions on uh, YouTube for this problem, but anyways, I am I have I'll so my video would be one of the solutions that you can refer to. So okay, now let us get started with the solution. So this is the intervals that I'm talking about. So this is the intervals that is been input in is a vector of vector ints. So this internal vector is basically a three length vector. First element being the left boundary of the interval, second element being the right boundary of the interval, and third element being the weight of the interval, right? Obviously we need to return the interval group, non-overlapping interval group with the maximum combined weight. Combined weight means that this is the weight of all the individual intervals that the group I mean weight of the sum of the weights of the all the individual intervals that the uh, group comprises of. Okay, so basically we are taking the size here, nothing here. Now we define interval, which is a struct. So why do we need this interval? So there are like two reasons behind this. One, we need to store an additional attribute called the index of the interval, uh, input index in the interval, because that is the one thing that we need to return as the answer. So that is one additional thing that we need to store. And then apart from that, we also need to be able to write a comparator or an operator which helps to compare between intervals so that our code can be precise, right? So because of those two reasons, we need to write this struct interval. So let us now go into this interval struct and see how it is structured. Basically we have this left boundary, right boundary, weight which is initialized to 0. So uh, uh, this might have some advantages, because suppose we want for a null interval, we would like to keep it at 0, because it should not have any weight to it. We'll see in the code where this helps, or even if it all this helps, but this is one initialization. Also, what another um, a reason behind initializing this as 0 is that if it is not initialized, I mean it is not initialized using a set of 4 parameters, then the value is 0, which is also helpful. But I don't have a strong reasoning right now. Maybe down the line in the code there would be a reason to look at why weight is set to 0, but that will come later. Okay, now we have this ID because we need to keep this ID because we need to return a list of IDs as our result, as I already mentioned. And we need to keep this operator because we have to sort the interval group. So there has to be a way of comparing two different intervals. So this means that this whenever we compare two different intervals using the less than operator, we will return a boolean value which will be either true or false. This basically means that uh, you keep uh, the current interval object and the other object. Okay, so it will be somewhat like this will be the current object, interval object, and then less than other object. We'll be using this comparison, and this would be the sequence if the current objects left uh, left boundary is less than the other object's right boundary. So other objects left boundary, right? So because we are basically what we're doing here is we're basically sorting a group of intervals using the start or the left boundary value of the intervals. Okay, that is what we're doing here. Okay, so this is standard operator, how operator overriding is done for structures, or operator definition is done. So if they're different, if the others left and then this left is different, then basically we sort based on the uh, or the left boundary value. Otherwise you have to sort by based on the right boundary value. Okay, so it's explained how this interval struct looks like. And then once this intervals once this vector list of vector ints of I mean once this original input of a kind of a I mean, uh, what could I say? I mean, vector content inside a vector kind of list is converted into a convenient list, which is a vector of intervals. Okay, then we need to sort that, and that we'll sort by using this particular line, and we have that operator defined, less than operator defined, and that would help in this sorting, as I explained. Now we have to define a DP array. So the maximum value the DP array can take is basically the number of intervals. I've taken, I think, I've taken a buffer of one here, and then what this value means, that the length. So this dpij here, so dp of ij would mean the basically a state given by intervals starting from I going till n minus 1, right? I to n minus 1, and the length, and the maximum length of items in this length of intervals in this interval group, right, should be j. That is what it means. So it's a state. I mean, state by state I would refer an uh, interval group, and then this interval group. So what is the, so this basically matlab stores the optimal weight, and the group corresponding to the optimal weight. The group would be defined by a list of IDs, list of original IDs, which is basically the last element of the interval, right? So basically it will basically, so from this we can derive the intervals uh, for this length of the subarray, sub and for this partial interval list which we have, and then we have them have a max cap of j length. uh, I mean, j intervals we can take here, and then and then each of that dp ij stores a state, which is basically the group, which helps us derive the group. And to derive the group, we need the IDs which comprise of the group, and obviously, I mean, from the IDs we can also derive the weight, but anyways, we keep that uh, combined weight also with it stored for easy processing during the uh, during during this program. That will be more clear when we move forward. So this is our DP array. Here we basically initialize it. So this makes this thing redundant, but we could actually not do this initialization, because once we are declaring, okay, pardon me. So this DP array has basically takes is an array of 2D array of states. So now I need to look at states. I think I mistakenly compared this weight with the DP array weight, but DP array takes its weight from here, from the state struct, since it is an array of structs, state structs, right? 2D array of state structs. Okay, so so now my system has gotten a bit slow for some reason, because the recording has been going on for quite some while. But anyways, I try to somehow push through. So this state has a weight, which is which as I explained, the combined weight of all the uh, elements comprising of the group, or the intervals comprising of the group, and these stores the IDs of the elements, right? And there is a is better comparison. What does it do? So this is better comparison basically looks, first of all, it looks at the weights of the two structs, which are state structs, which are being compared, and gives more priority to the one which has got a more weight, which is logical. And then what it does, if two have the same weights, this is pretty sleek code here, this line. if both these structs have the same weight, then what would happen is this line, what it does is it looks at the first elements of both the interval groups, or first intervals of the both the interval groups, and then the compares the left boundary of those first intervals. It compares the left, or oh, pardon me, yeah, and it compares those two first intervals of the two groups which are being compared, right? And and we have already set a operator, less than operator, for the two for intervals. And what that would do is, that will take the interval which has the lowest value of the left boundary. So I'll explain it in a here. So I think my system is slowing down. So basically, I'll probably edit here. So okay, so let me explain you what this is. Uh, I had to restart the video again, so I'll just maybe just club these two videos together. But anyways, so suppose there are like two lists. For now, compare, just assume that these two links are of like two length, right? So now both these lists have give you the maximum same combined weight value, right? Here in actual scenario, this both these two lists can have any value which is less than equal to 4. But anyways, for now, compare both for now, assume that both the lists have got two intervals in them. So now we are what this uh, what this operator would eventually end up doing is, it will compare this and this, and we already have a comparator to do this, right? We already, in the intervals, because these are interval structs, and we already have a comparator which does this. What it does, it basically returns the left value, uh, uh, basically uh, 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 basically favors the interval which has the lower left boundary value, right? So if this is L1 and this is L2, if L2 was less than L1, then this will be basically favored. This will be basically taken as is better, right? This is better. So hopefully I was able to explain. Now let's keep moving forward. We were here, we then initialized our DP here. Then, okay, now this is our main loop. So this is our main DP loop. So we'll be, so why is, first question is, why is I decreasing with every iteration? Why is j increasing? So the main concept behind a DP computation is, if at a particular state, and by state I would mean I would point to ij, a combined ij value is referring to any other value, then that value has to be pre-computed before that value, uh, 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 when that value is getting referred to by the current ij value, right? So basically, if you look at how this code works, I'll explain each and everything now, but I just want to notice something. So you can see that we are referring to the I plus 1th value, and here we are referring to the j minus 1th value. That means we need this to be computed by the time we enter the ij loop, right? Hence our I loop has to run backwards and our j loop has to run forwards. That is the reason of the directionality of the flow of ij here in the loops. But anyways, now what, let's see what you're doing. We're just storing the attributes of the current interval, right? And then what were we doing? So we have two choices: either we skip this interval, right, or we keep this interval. So we are trying to form a group here. So basically we are trying to form the optimum group or oblique state for dpij. And then for that we are looking at the ijth we are looking at the ith interval, right? Here j refers to the maximum group length that we want to consider. Okay, that puts limit on the maximum group length. So anyways, we're looking at the ith value, and now either we can take the value for this j length group starting from I going till n minus 1, or we can leave the value. These are two choices, or pardon me, where we can leave the interval. Either you can take the interval or we can leave the interval. These are the two choices that we have right now. So what if we skip the interval? So then basically we boil down to uh, dp I plus 1j. This is self-explanatory, so I will not be spending time on this. And then what if we take the value interval? Then obviously we need to figure out another interval, which is another next interval which is non-intersecting, right? Which it has to be non-intersecting, because all our groups are comprised of non-intersecting intervals. So I have a very short function to do that. It uses binary search to optimize this step too. So let us look at this function and what it does. It takes in our list, right, our modified list, which has the additional id as the fourth element, and then it takes the current's end time, because we are looking for an interval which has the left boundary greater than the current end time, which will make sure that it is non-overlapping with this current interval, right? And we have this id which we are taking as input, because this basically denotes the start of the start id of the interval from which we should be looking at. I mean, suppose our current end time, this interval was id, so this has to be id plus 1. This is essentially what it is, right? So, okay, so we'll set low here. This basic, I mean, binary search. We'll set the high to the maximum value, low to the minimum value possible. Our answer will be -1. If our answer is -1, basically we are not able to find any interval such that it's any interval with id and beyond up till n-1, such that its left boundary is greater than the current n type. So on non-overlapping interval exists from I plus 1 index and beyond, right? So that is what it means if answer remains -1. So then we calculate the mid here. We set this generic binary search criteria for breaking the loop. We set the mid here, and then if this mid satisfies this condition which we are looking for, we set it. This equation can be run multiple times, but every time I think the last time when it runs would capture the I mean the most nearest I mean id which we are looking for. So basically what we are looking for here is the nearest id to greater than id which is passed here, or more, which satisfies the criteria, the non-overlapping criteria, right? So basically, let me reframe this. Maybe I did not put my words out right. So what we're looking for is, given the interval, the next eh, the next closest interval on the right of it, right, uh, which is non-overlapping with it. That is what you're looking for. Uh, and finally answer would store that interval id, right? id of the interval, or the interval index in this list, interval with ids, right? Okay, so then we just this is normal binary search. We set it say high to mid -1, because we already checked for mid here and then noted down the value of mid in the answer. And then so basically high needs to be moved lower, because our left is always already larger, already satisfying. So probably we need to move high closer, which will also decrease this value, because we're basically moving to the further inside or further leftward, so that would potentially decrease this left boundary value, right? So that is what we are looking for, this simple binary search code. And then opposite thing will do when this doesn't match, right? If the left is if the left is lesser than current end time, then we need to move rightward. So that is what this does. So this is about the binary search code. Okay, so now and then there is one okay, so now these are all we are doing because we want to solve the scenario or come up with a state when we take the current interval, right? And then what happens when we take the current interval where we don't find any id, no non-overlapping id to the right of it? Then obviously uh, our state or our group would only comprise of itself, nothing else, because we could not find anything to the right of it. So the group would only comprise of itself. So the group of IDs would only be the current ID, and the weight would be the current weight. But if it is able to find the next ID, then what we'll do, it will use the pre-computed DP value of next ID and j-1 to get populate its weight, and then the pre-computed value of DP next ID and j-1 to populate its ID. Let's look at what these three lines do. This is basically to keep the IDs sorted, right? Because this will help in the comparison, because if the IDs are sorted and we are comparing two groups, then we can make sure of the lexicographically graphical criteria, right? Because first we'll compare the weight of the groups, and then since the IDs are sorted, we'll always look at the minimum ID, and then and compare the minimum ID between the groups, and then for the minimum ID we'll basically look at and the minimum ID will come at the first location, obviously, because it is sorted, and then for that minimum ID we'll be looking at the left boundary and comparing the left boundary between those two intervals of the two different groups, and then take the group which has the first interval, which has the having the lower left boundary value, right? So let me explain this again. So this ID sorting would make sure that the minimum ID, right, the minimum ID is always at the top, always at the leftmost end, and same for the second group, and then we can compare their left boundary values. And so this ID also is very important for that lexicographical sorting, right? So uh, this also is one of the reasons why we are taking IDs here. One, because we need it for lexicographical sorting in this line. That's why we don't take the initial list and then process it. We add some the ID value to the end of it and then start processing. So this is useful in the uh, in populating the answer, which will come to later, and then this also helps in sorting. So I think the sorting part I missed here, but as you can see, now it is clear that it is also useful in sorting. So okay, and then we compare take and then skip, and whatever is better we'll populate dpij with this, and then we'll finally use dp this final dp04 and IDs as the group which has one and which is the maximum weight, and also if it shares any other if shares is maximum weight in any other group, then it is pretty sure that it has got the lexicographically smallest value, right? So as you can see, this is a pretty difficult problem to figure out, with a lot of edge cases, and it uses binary search and some C++ structuring, sorting, knowing some of how C++, knowing uh, uh, some uh, very niche C++ rules. Yeah, so all of this combined, this is a pretty hard problem, and then hopefully I was able to explain it. And see you in the next video. Thank you. Bye.